Welcome back. We're going to be doing day 3. Let's see how it goes. Okay, so our definition of symbol is going to be anything that's not a dot. Acceptable. But how can we do this in a nice way? I'm not sure what's going to happen. We're just going to see. Let's say we have the grid, and we have a line. While we read in lines, put that into the grid. Put the line in the grid. Okay. For each line in the grid, print out the line. Make sure we're reading an input correctly. Okay. Maybe I can read the numbers at every digit. I can check if there's a nearby symbol. That's a lot of work, and don't know how part 2 would turn out as a result, but I honestly don't know what else to do. So that is actually going to be our plan. So we have a sum. At the end, we'll print out that sum. Now we can do some pretty bad loops. I wouldn't really like to do it like this, but oh well. Say we have a number that starts at 0. If the current number we have is a digit, we'll multiply the number by 10 and add the number that we just found, converted from ASCII to an actual digit. So if we start with this one, 4, 40 plus 6 is 60, 70 plus 7 plus 460 is that. So we should have the number, but we have to keep track on whether we have a symbol or not. So you know what, it starts at false, and if we find a symbol, then it's true. Okay. So if we don't have a digit, we must stop. Okay. That means we'll add it if we have a symbol, then we can add it to our sum. Then we can reset our numbers to 0, reset our symbol, symbol, we can reset our symbol counter to false. Okay, now we just have to find out if we have a surrounding symbol, which means I have to check up, right, left, down, top, right. Oh, I have to check the gonna push that into a separate function. Symbol neighbor. That's gonna take the grid and our current position. I think if I can write this function correctly, then we are all good. Gonna do some bounce checking like this. This is very error prone, but oh well. That's how we can do that. So that checks to the left, or that actually checks above and below. Let's do left and right next. Okay, this also has to be not a number. Yeah, that's not... I don't like how much repetition this has, because now I have to do that for all the cases, but I'm already halfway done. There's only 8 possible neighbors, so I'll just suck it up, and if it breaks, then that is the consequence I must deal with. So that's half of this, okay? Next half, it's gonna be doing both at once. So that's really just combining. It's gonna be combining both of, ooh, see, that's already an error. It's gonna be combining both of these conditions together. So this does one above, so this does up, down, left, right, top left, bottom right. So we have two conditions left. Oh, also, at the end, if we have no symbol, return false. We only check for a new symbol if we haven't found one yet. These should also be J. Oh boy, okay. This is going to be one below to the left. And then we want to do the reverse, which is one above to the right. There's like no way this will actually work on the first try, but whatever. Gonna get an index error. Oh, we didn't. And that is actually the correct answer. Okay. Let's see how this handles the big case though. I don't know exactly how it handles certain cases, like maybe that causes issues. I'm not sure yet. Not the correct answer. Okay. As I suspected. But we're not doing terribly, so we might be able to fix this in a reasonable amount of time. So one of these must be not correct. Or let's go back. Oh, actually, if in the default case that's actually in there, then so I believe this handles numbers above correctly. Okay. So all of these are getting detected correctly. 58 and 114 are not. So those are not supposed to be there, which is good. So those are being handled correctly. Just make sure it's not that many numbers. Okay, let's try to do certain things to mess with this. Let's say that's what we have instead. We should get the same answer. Okay, we do. Any number adjacent to a symbol, even diagonally, adjacent to. So my question is, if the dollar sign was to the left, it would still count, right? We don't have an exact example of that, so. Is adjacent to a symbol. Yeah, okay, I would believe that means that even if the hashtag was here, this number would still count. So perhaps it's something small inside of here, which is not good because there's really no way for me to easily debug this. Start at the top. What's this? Okay, so those match. Let's make sure that the sum isn't too small to handle. I don't think that's the case, but you never know. Okay, well, let's test it with the new input. None of these numbers look that big, so. You know what? That number is too big. We only have numbers that are 3 digits, so at some point, we're not resetting. And I think the point that we're not resetting at is when we change lines. So at the end of each of these, we should reset. Symbol should be false. Well, actually, nope, that couldn't be the issue. Okay. How should I phrase this? I am suspicious that we're getting big numbers because maybe if there's a number there and there, it's not getting reset, but that might not be correct. What might be tripping us up is something like that. That could be counting as a really big number. So what I'm going to do is test out that number that we're getting. And you know what? It's good to have the digits, the index as well. So I'm betting that we'll have somewhere in our output, we'll have 606,974,000, you know, some big number. We don't, so we get something else. Okay. So let's try to find this 74359. Okay, so that's not getting reset when it should be. Why? Okay, so some of the numbers are not getting reset. Why would that happen? Three, 6, 7 also doesn't get reset. It goes to 895. So the conditions for resetting are too stringent. This condition should always happen. Believe that was the mistake. I was only resetting. Yeah. Okay, that number looks smaller. Hopefully the correct. No. Okay. Right. Well, that still is a more correct answer. It's a lot smaller now. Was I told it was too high or too low? Doesn't say. Okay. Well, let's make sure that we're still doing the input correctly. The test data, yeah, that's correct. Okay. Let's see if any of these numbers are too large. They are fairly small. Let's some checking. That looks good to me. It's right there. $27 looks good. 492 looks good. 234 is 919. Interesting. Because they're not adjacent to a symbol. What if you're adjacent to two symbols, perhaps? If you... Is that part of the problem? Periods do not count as dots. 'Cause it just occurred to me I could do something like this. Doesn't really matter, but yeah. So if it's already false, and it becomes true, it'll be true. If it's true, it'll stay true, even if this is false, which is fine. So are we finding numbers that shouldn't be there? But the question is if we have too many numbers or too few numbers. Let's do it by hand for a bit. Looks good. Looks bad, so it's not there. Looks good. 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 367 is bad, shouldn't be there. 895 is good. 899 is good. 26 is good. 220 is good. Let's look at some possible edge cases that I want to find. Let's go there and see how. So 752 is at line 27. It's there. 276. 470 is good. These are all correct, I think. $848, line 26. Yeah, that's there. It's not doing numbers multiple times as well, so I'm currently under the impression that we're missing numbers, perhaps, or it's something very subtle. Let's make sure that the answer isn't polluted by accident. Make sure I copied it correctly. No, that's the answer I had. Okay. Four, three, six, one. See how people have done. And that's not a lot of people, so there's a lot of edge cases here. By this point, I believe 5,000 people had completed the first part, so only 2,500 or so have. So I'm not terribly behind, actually. Edge cases, there must be an edge case here. Am I missing numbers, or do I have too many? Let's look for a number that is surrounded by two symbols, if any number exists. So one symbol, one symbol. I don't know. I guess I'll write my own test cases for now. Let's have a little dot grid. Probably best to do that. Okay. Actually, this actually. Wait. Is each. Okay. So that's there. Let's toss out the hashtag. Okay. Yeah. Hashtag is there. Let's try this test case. 11. Found it. What just happened there? We swapped. And I didn't add it. This should be 12. Okay. I think I found the problem. I guess no matter what I do. Shoot. Oh, wait. Okay. So what happens? How do I get to this stage? Okay, so I have to be at the end of J. I have to be at the end. And I have to be valid. So why isn't that getting added right now? Well, if we get to the end, we never get to this else statement. So if it's not a digit, or j is equals to grid ice minus 1, wait. That. Okay, so if we're at the end of the input, make sure to add what we found. Huh, that doesn't fix it either. Okay. Sorry, I meant to say and. No, okay. If we're at the end, okay. Gonna split this into 3 conditions now because I haven't thought about this quite enough yet. So, are these distinct conditions? make sure order of operations aren't messing with me. I don't think they should. Okay, let's make sure we're doing anything right. Should have 3 ends. I'm getting nothing now. Skeptical if this is actually listening. We should get 12 if it is. Okay, so this condition never gets hit. Okay. Because it is a digit. This is our problem. Okay, so if we have a digit, but we happen to be at the end, then as a sub-branching condition, we must do the whole song and dance with adding stuff. We should get 13. And 3 ends. Or 1 end, whatever. I believe that's the issue. So we were missing a case where the number would be at the end of the line. I wonder if that was obvious in the data we had here. Let's see. So yeah, that's a little bit bigger. Yeah, that was it. How is that? That's not awful. 3,000. Let's go to part 2. I'm very worried about this. Okay. Gear has to have that symbol, okay. Adjacent. And adjacent means diagonal as well, correct? Even there, okay. Find all of the ones which are okay. I was worried they would do something like this, so until now my problem is now inverted because I was looking for symbols around numbers. Now we have to look for numbers around symbols, which is slightly more difficult task. I have thought of a way to brute force this, but I would prefer not to do it, so let's not be hasty on that. Okay. So part 1 is to figure out, well, it's easy to figure out if, well actually, okay, it's less easy to figure that out than I thought with my method. So vertically, which of these are surrounded by exactly 2? We could do this with sets. We could say that every number keeps track of the coordinate of the symbol it's next to, and we could have a set union of all of the numbers with the same symbol coordinate that is a star, and make sure that the set size is 2, and if it is, multiply them together and add them. Is this harder than I think? Right. So I'm gonna put this in B now. Instead of that being a bool, what if we say there's possibly Actually, nah, let's still keep it a bool. Right. Oh. That's what we should say first. Yep, should have done this in a more unified format. Now you can see that I'm gonna have to copy all of this over and just hope I don't make a mistake. And it inevitably, it probably will be one. But maybe not if I focus. Okay. Plus plus, minus minus, plus minus, minus plus. So now this should only give us the symbols which have gears. Okay, so what is this gonna tell us? Let's say we have a set of I have a way of doing this, but the time complexity is like n cubed, maybe even worse. So let's try to have a slightly better way. Okay, so this tells us we found a symbol with a gear. This is important. What can we do with this information? Well, we can say that we have a number that has this coordinate. Perhaps we could keep that in a map, which is a pair of ints to a vector of numbers? Something like this. Instead of adding it here, what we're going to do is say go to the record, go to ij, and add our number. I mean, only problem is, how do I even find a sum now, though? For the coordinates and the vector of numbers we have inside of here, inside of record, if we have exactly two numbers, sum will be the one in the front. Well, actually, no. It's going to be the first one plus the second one. Not super convinced on that. That doesn't... Oh, actually they multiplied too. Okay. Ooh. Yeah, okay, well we got 0 too, which is really no good. Okay. That's... Are we getting any numbers from this? Curious. Let's do some reformatting to this. Wait, that's not right. not correct. Oh, because we've been using ij. Ij is the digit we're on. It's not where the grid is. So where the grid is actually, well, it's wherever we found it. So we can't just return that anymore. Oh, that's annoying. We can return a pair of a bool and a pair of coordinates. Yeah, not really how I wanted to do that, but it is what it is, and I think it's technically correct. So yeah. This really should be an optional if you want to be technical about it. That would be a 1% smarter way of doing it, but I also don't care. So the real miracle is that I haven't messed up this part almost at all. So that I am surprised about. Again, technically that should be nothing, but we'll just put in garbage data. That, I believe, is more correct. Wait. Okay, also I just realized that okay, so this is no longer what we really want. So this is, I think, closer to what I'm trying to say, which is that if we have our grid, then we're good. If we don't, then we don't. Oh, oops. Okay. I should probably sit down and think about this for a bit, but I don't really feel like doing that. Oh, I like that. Okay. So now what we're really saying is that we always have a pair of coordinates right. Okay. So now that I have the actual result, what can I do with that? So supposedly I can't use symbol now. Let's just have the result. If results found something, that means we have the gear, but we don't have to do anything yet. So maybe chords equals result. So what now this means is that if we have chords, if chords has a value, then push in chords the value that we have for it. And at the end of this, chords probably needs to be set to what's it called? Null option, yeah. Or just nothing. I think I prefer nothing. Yes, probably other problems with that. Let's just see if it runs. I'm not 100% sure what's gonna happen. No, that's off. Well, it's not that off. So what's interesting is we're getting, is that what those are multiplied together? It's not horribly off. Okay. What it doesn't seem to get is that 4, 6, 7, and 35 have the same. Okay, so I'm detecting them correctly, but they're not finding, I'm not treating it as if it's in the same, actually, that's a very strange issue to have. Doesn't seem like I'm treating it as if it's the same coordinate. So let's look at what we're getting. They should be the same, but they're not. Let's figure out why. Okay, so this one claims it's at 1, 2, the other one thinks it's at 1, 3. So this one thinks it's here, the other one thinks it's there. Well, can't really see anything now. Ugh, you know what? Let's do that. Yeah, so these are together. How are they one off? That's surprising to me. Yeah, that one really makes no sense. Maybe I did have a typo, finally. Well, if it's a typo here, I actually don't see it, which is troubling. But it's close. Okay, so the idea is actually not bad. I'm glad that actually worked. Okay, yeah. I feel less bad about this now, even though it's taken 50 minutes. So I just need to find a way to get those to be the same. Close that. Well, it's not really is yet. It's just saying symbol here. That's a slightly more accurate name. Okay. Yeah, so the logic should be actually quite similar to what I had before, just with, excuse me, optionals instead. Extra line. Alright, those are supposed to be equivalent. If it exists, do something. If not, then don't. No? So these numbers should be 1, 2, and then 1, 3. Hey, there's 2 1, 3s, and that is the correct coordinate, so why is it not being overridden? Oh, it's being found twice. Is that what's happening? Actually, it doesn't matter if it is. Wait, let's think. Where does 1 and 2 come from? That one makes no sense. That's here. That's not the right answer. And this actually corresponds with... Well, let's find out where we're getting each of these values from. So... Well. So... Let's do it like this. Hopefully I can get this done for 1 o'clock. I'm tired. Good. Yep, that makes sense. No, wait, that doesn't make sense. That's not 1, 2. That's 1, 3. Maybe my down 1, right 1 is broken. That's +1, +1. Okay, gonna do a little... If that goes off, then it's triggering correctly. Huh? No! Oh, okay. There was a typo, and it did end up costing me, I don't know, 5 or 10 minutes. Yeah, that was bound. There was no way that wasn't gonna happen. That's now the correct answer, yes. I mean, who's to say if this is correct as well? I don't know. That looks too big. I'm done. Okay, that was done before 1 o'clock. Let's look at the stats. Just below 4,000. Not amazing, but not terrible. Now let's peek on my friends. I was first. See, this guy did the first one. That means I won now. Alright. Okay, let's get rid of the errant print statements, and I think I'm just gonna upload this with no further changes. I mean, I would like to make this not horrible, but I don't really care is the problem, so I think I'm gonna leave that as is. Actually, is there any final stupid thing I can try before 1 o'clock? Actually, no. You know what? No, it's not. Okay. See you tomorrow.